this video, we are particularly dealing with different types of functions. We will be discussing the mathematical representation and the graphical representation. In all cases, we are defining a function mapped from R to R. Let's see one by one. First one, identity function. Identity function is a function which returns the same value as the input. Define the real value function R to R by y is equal to f of x is equal to x for all x element of real number. Now, what will be the domain and range of f? Domain will be equal to the set of real numbers. Similarly, the range of the identity function will also be equal to set of real numbers. Now, what about the graph? It is a straight line passing through the origin. Next, we will see the next function, that is constant function. Constant function is a function that has the same output no matter whatever your input value is. The general format is y is equal to f of x is equal to c, where c is a constant. And now what about the domain and range? Domain of the constant function is equal to the set of real numbers, and while the range of the function f is equal to set c, because all the output values will be c, the constant c. Now if you look at the graph, it is always a line parallel to the x-axis. So here y is equal to 3. In this figure, y equal to 3. It is parallel to the x-axis. Let's see the next function, that is polynomial function. Polynomial function is a function which can be expressed in the form of a polynomial. Polynomial function is of the form f of x is equal to a0 plus a1x plus a2x square plus up to an x raised to n, where n is a element of a non-negative integer. A polynomial function has only positive integers as exponents. Identify whether the given function is a polynomial function or not. First question, x raised to 4 minus 1. What is the degree here? We know the degree here is 4, right? 4 is greater than 0. It should be a non-negative integer. Now, is it a polynomial function? Yes, it is a polynomial function. Let's see the next question. 2x raised to 3 by 4 plus 4x minus 1. What is the degree in this case? Degree is 3 by 4. Alright. Now, is it a polynomial function? No, it is not a polynomial function. Next question. 8x plus 3 by x. So, 8x plus 3 by x, we can write it as 8 plus 3 by x, right? Now, this can again be written as 8 plus 3 into x raised to minus 1, alright? Now, say degree of this. Degree here is x raised to minus 1. So, degree is minus 1. And is it a polynomial function? No, it is not a polynomial function. Let's see the graph showing f of x is equal to x square. The graph is like this. Domain of f is x such that x element of real number, and the range of f will be x square for all x element of real numbers. Now our next function is rational function. Rational functions are functions which represent the ratios of two polynomial functions. Such functions are of the type f of x by g of x, where g of x not equal to 0. For example, f of x is equal to 1 by x. Now create a table and see the values of x and y. When x is equal to minus 2, what will be the value of y? Y is equal to 1 by minus 2, which is equal to minus 0.5. So y is minus 0.5. Similarly, when x is minus 0.5, value of y is minus 2. And when x takes a value 0.25, value of y is 4. Since 1 by 0.25 is equal to 4. Now, when the value of x is 0.5, 1 by 0.5 is equal to 2. So, value of y here is 2. And when x is 2, value of y is 0.5, since 1 by 2 is 0.5. Now, if you plot for more values of x and y, the graph looks like this. Like this. Alright. Now, what about the domain and range? Domain and range is a set of all real numbers except 0. That is, domain is equal to r real number minus except 0. So, r minus 0. Here the range is also all real numbers except 0. That is r minus 0. Alright. Now, it's time to see the next type of function, that is modulus function. It generally refers to the function which gives positive values for any number which we give as input. It is also called as absolute function. Absolute function. And it is represented by modulus of x. This is a representation. So, our f of x is represented by f of x is equal to x for x greater than or equal to 0. It is equal to minus x for x less than 0. For each non-negative value of x, f of x is equal to x. But for negative values of x, the value of f of x is the negative of the value of x. For example, modulus of 5 is equal to 5 itself. And what about minus modulus of minus 45? Modulus of minus 45 is equal to minus of minus 45, which is equal to 45. Now, let's see the graph of a modulus function. Modulus function, the graph is alright, this is a graph that is for all positive values of x. The value of x will be positive x, and for all negative values, again the value of x will be positive. Let's see the next function, that is sigma function. This function attributes positive 1 for positive input values of the function and attributes negative 1 for negative values of the function. Mathematically, we can write it as f of x is equal to 1 for x greater than 0, and the value of f of x will be 0 for all x is equal to 0, and the value of f of x will be equal to minus 1 for all x less than 0. Now, what about the domain and range? Domain of the function will be equal to r, and the range of the function will be, what are the values here? Minus 1, 0 and 1. And the graph is So for all positive values, the value of the function will be 1, and for negative values, the value of function will be minus 1. And the last function is the greatest integer function. Here, the function assumes the value of the greatest integer less than or equal to x. It's also called as floor function. It is represented as f of x is equal to x within the square bracket. For example, for minus 1 less than or equal to x less than 0, the greatest integer function will be, what is the lower value? Minus 1. So, greatest integer value function will be minus 1. Now for 0 less than or equal to x less than 1, the greatest integer function will be equal to 0. Now for 1 less than or equal to x less than 2, greatest integer function will be equal to 1. And for 2 less than or equal to x less than 3, the greatest integer function is equal to 2. Now another example, if x is equal to 2.8889, what will be the greatest integer function? The greatest integer function will be equal to 2, because 2.889 lies between 2 and 3. So the lowest value will be 2. So the greatest integer function will be equal to 2. And the graph of this function is, for 1 to 2, the value is set at 1, and for 2 to 3, the value is set at 2. Alright. So for minus 1 to 0, the value is set at minus 1, and for minus 2 to minus 3, the value is set at minus 2. Alright, like a step function. So we have discussed all fundamental types of real functions along with their mathematical representation, and the graphical treatment for the same is also done for better understanding. Remember, we have discussed identity function, constant function, polynomial function, rational function, modulus function, signal function, and greatest integer function.
Manorama Horizon. Learning made simple.